of equipment here is actually what they used to use on the space shuttle, now retired recently due to money issues and all that fun stuff. But the whole idea behind this metal was we needed to create something that reflected heat, okay? Because any kind of regular metal will heat up and be too hot to the touch, cause damage to anything else that it's touching. Okay, so the molecular structure of this metal is exactly what I drew here. It's light and it's compact. So what it does, it creates a layer of molecules on top. So when the heat comes in, it bounces right back off, as I will soon demonstrate right here. Back in the 70s, they had this material that vaporized every time you came back into the atmosphere. Okay, very similar to the stuff I'm about to demonstrate, but not as dense. Okay, very kind of farther apart like this one. So what ended up happening was the heat would transfer through and vaporize the metal every time it came back into the atmosphere, affecting the safety of the astronauts. Now it's a good idea. We're going back to the capsules now, as SpaceX and them are doing. They're designing called the Dragon capsule, and that's what they're using now, except with the more advanced material that I'm going to demonstrate. But now, what this stuff does, like I said, like I'm going to demonstrate, bounces the heat right off. Now, an interesting fact is, when a shuttle re-enters the atmosphere, the shock forms and it creates a temperature that's 100 times more, 1,000 times more than it should be. Okay? Does anyone know what the surface temperature of the sun is? Just curious. About 5,000, 6,000 degrees Fahrenheit. Re-entry of the atmosphere is about 2,300 degrees Fahrenheit. So when you're dealing with such dramatic temperatures, you have to have a material that'll reflect and do its job properly. So when you see the material, when you see the heat hit the material, it reflects right off the side. You see that? Okay, no other metal will do that. It'll absorb the heat and it'll get really hot. What this does is it keeps my hand and all the astronauts that it used to protect safe. Okay? I'm not using a glove. I'm perfectly fine. Okay? So if you guys want to touch the side here, any other metal will be too hot to touch, but go ahead and touch the side right here where my finger is. Okay, it's completely cool. All right. Now what happened, I don't know if you guys are familiar with the Columbia, right? Back in 2000, this is what actually donated to us from NASA by the Columbia when they redid the tiles back in the 90s or whatever. Well, I mean, they redo them a lot, but this is one of the times they were like, yeah, you could have some of our tiles. But what ended up happening, a piece very similar to this, during liftoff, broke off and hit the wing. Okay? Now what it created was a crack no bigger than about, no bigger than like this. Okay? Very, very small. Now upon re-entry, do you guys know what happens to metals and other materials when it heats up? It expands. Okay? Now when a metal expands, this crack gets bigger, okay? Now when it gets bigger, anything else can get into it, temperature, pressure, whatever. What happened to get into this one was air, okay? And what the air ended up doing was slicing right through the shuttle. Now I don't say pressure, I'm not saying heat wrecked the shuttle, I'm saying air ripped through it like a knife, okay? So that's what we have to do. Our whole goal here is to protect our astronauts by designing materials advanced and safe enough so that doesn't happen, okay? Does everyone have any questions? Yes, sir.
Can you touch the part the fire hit?
No, that's hot, and that's the whole reason. The energy has to go somewhere, so that's why it's right there and not anywhere else. Because if you think about it, the shuttle's here. Let's pretend I'm an astronaut. The heat hits here, bounces off, instead of going through and affecting me. So it's got to hit somewhere. Okay? You guys have any other questions? All right. So now, what this is an experiment that we do on our atmosphere, in our atmosphere, which affects, because we know that space is very expensive to do experiments in. And as you can see in the next exhibit here, if you guys are interested, they're going to do some more experiments to demonstrate how we can experiment with spatial conditions in our atmosphere. So, all right, guys.